Hi, this is the IFC Architect speaking, and today I'm doing something a little bit different. You're going to be seeing what is essentially a workshop or course that I created and initially distributed locally for architects. It involves an open source architecture workflow using different tools that are all open source and free that complement BlenderBim, and BlenderBim is one of those tools, but essentially this is about everything else. Even though BlenderBim is in this, it's not going to be anything new if you watch this channel. But I thought this would be maybe helpful if people want to see a workflow from an architect's point of view. I'm not very proficient in all of these tools. I use them day to day, but there are people out there who are magicians. This is just an introduction. It's a stepping off point. I hope you find something useful, and I hope it is insightful, at least. All right, we're just going to get into it.
This is the 2D, 3D workshop. This is an open source architecture workflow. Today is just a showcase and introduction. If you see in the corner there, this is an AI generated image. You can probably tell by those, what looks like text writing in the top right-hand side. The technology is pretty advanced, and I think everybody should be looking at incorporating it into their workflow. And this is from an open source version called Stable Diffusion, and we'll get into it later on. What's happening today? It's not too much. I've got these 7 broad categories to hook us together. The first is what is open source, which we're going to get into in more detail. The second is photogrammetry. It's the process of taking photos of a site or a building and then stitching it together to create a 3D model without having to measure it. The third is just an example design concept using some tools. The fourth is project documentation, its drawings. The fifth is a presentation work, video rendering and still rendering. The sixth is a cost comparison, also a performance comparison. And then the 7th is the AI image generation. So what is open source? Open source is essentially free. It's software or a platform or a system that is free to use and free to use for whatever you want, essentially. It doesn't restrict you like Google Maps, where the content and the data is the only thing that you're allowed to use. Most open source software, you can download it, you can edit it, you can create your own software out of it. And it's also free, as in free lunch, free beer, which means you can use it for free forever, essentially. And those examples from the poll, Wikipedia, OpenStreetMap, and Ubuntu are examples of open source software, which are different from just your typical free to use software like Facebook, Google Maps, Instagram, TikTok, social media, and those kind of things. Okay, so everybody's heard of Wikipedia, basically. Wikipedia is the largest example of an open source project. I'm sure everyone uses it every single day. It has its flaws, but we know how useful it can be, and especially it has to do with its referencing system. Anything that's said in Wikipedia has to be referenced, and it makes it very useful for checking sources. It makes it more useful than most articles who don't put references in. OpenStreetMap is effectively the Google Maps of open source systems. It's been used heavily in disaster areas, in areas where there's lots of refugees. Essentially, the difference between OpenStreetMap and Google Maps is anybody, like Wikipedia, anybody can contribute to it. So it can be updated incredibly fast. Most recently, it's been in the news for the earthquakes in Syria and Turkey, because Google Maps takes so long to update their maps. The difference is you can have people on the ground walking around a building or tracing up-to-date satellite imagery and give people day-to-day updates. So that's a place where it's been used. And then Ubuntu operating system. Ubuntu is a free and open source operating system like Windows or Mac. And it was made by Mark Shuttleworth, a South African. That's why it's called Ubuntu. And it is the largest free and open source operating system in the world. Not nearly as big as Windows or Mac, but the 3rd largest in the world. So just something to consider. I'm not going to be using Ubuntu today or OpenStreetMap or Wikipedia, but these are examples of what an open source ecosystem or software is. In this case, the 2 are websites and the 1 is an operating system. But today we're going to hop into some open source software similar to these that we are going to go into. Okay, cool. We as architects understand that as a technical definition, it's not just the art or practice of designing and constructing buildings. We understand that it's more than that. It's about creating space. It's about creating spaces that people play, work, and live in. And we facilitate that through a structure and a shelter. And a big part of that is the conceptualization of those things before they get built. And I'd say it's 50-50, that conceptualization before and the construction on site. I want to place emphasis on the first half, the conceptualization, the design of that space. It's in that process before the building that separates us from builders, worksmen, and tradesmen. It allows us to experiment and push ideas further. And it's that process that is being held hostage right now, which I want people to consider. So building information modeling, or BIM, is by technical definition, the process supported by various tools, technologies, and contract involving the generation and management of digital representations of physical and functional characteristics of places. That is the Wikipedia definition. If you look at South Africa, we have a BIM Institute, and they have a website of their own. And unfortunately, it's down right now. But thankfully, because of an open source project called the Web Archive, we can check what their definition of BIM is. So it's called the Wayback Machine. I don't know if anybody's used it, but if you ever have a website that's down, you can check what it looked like at a time when it was up. So in the South African BIM Institute's definition of BIM is an innovative technology and process that has transformed the way buildings are designed, analyzed, constructed, and managed. I prefer Wikipedia's definition, which focuses on the actual process and not on what we think of it in hindsight. So like how the Wayback Machine, which is an open source available project, has helped us see this, many other open source projects like Wikipedia and Ubuntu and OpenStreetMap have helped other people use their projects throughout the world, essentially. More practically about open source, it refers to an idea that's something that doesn't need to cost anything, like an idea, a technique, a digital book, or a software. Something that can be copied and distributed for free shouldn't have a cost, essentially. Sometimes it's called copyleft, and it's the basis for the workflow that we're going to be using the whole of today. The one I'm going to be talking about the most is a software called Blender. I'm sure some of you have heard of it. This is the largest free and open source 3D modeling tool in the world. And it is free, it is constantly updated, and it is incredibly powerful. It's one that I'm going to be using the whole of today. It's been used from tiny animation and game studios to high budget TV shows and even Marvel movies. And if we go to, like, let's say the features here, you can see the different ways it's been used, and you can see the level of quality when it comes to rendering that you can get out of this. Essentially, it is a 3D animation and visualization modeling tool. The last one that is an addition to Blender that we're going to be talking about today is an add-on to that, which is essentially like a plugin called BlenderBim. And then this is the portion where it's applicable for architects. BlenderBim is an add-on that was developed initially in 2019. And what they thought was that Blender is an excellent 3D modeling program. But what would happen if we turned that into a building information modeling program? And they essentially started to get going. They made a rough add-on, which was like 78 kilobytes or something, which just allowed you to import and export IFC models, which is the industry standard for data exchange, into Blender, and then export them out, edit them and export them. IFC stands for Industry Foundation Classes, and it's essentially a set of agreements for describing a building in like a digital space. It's not limited to 3D geometry, and it can even describe contracts like written contracts and more abstract things without geometry, like thermal conveyance and resistance values and all of that. More practically, it can be used as a file format, that being the .ifc file format. So the IFC is handled by a nonprofit called Building Smart. So they are an international nonprofit, and they basically look at data exchange, technical documentation, definitions, that kind of thing. Their whole process, IFC is just one part of it, is that any file should be able to be opened in any other program. So if you make a file in Revit, it should be no problem to open that file in ArchiCAD. It should be interchangeable, and you shouldn't lose any information. Unfortunately, practically, that doesn't really work out. As we all know, anybody who's used Revit understands that even if you upgrade and you create a file in Revit 2022, you cannot open that file in Revit 2021. And IFC, which is a format to export that into, is one of the ways to get around that. And I'll just be going through that over the course of the day. So what is the future of architecture with these open source projects? I honestly think it's just about adaptation. I think for the most part, if we look at Revit, that is the international standard, which is owned and operated by Autodesk, it's just one of many. Whether that's AI, or a few years ago, everybody was talking about algorithms, whether it's an app or just the internet, these are just tools. And if they're not useful to you, or if they are, you can just find how they can be useful for you. But just remember, it's pen and paper, it's cardboard and glue, it's string and clay, and then hopefully you can see how capable and powerful it really is. All right, we're going to start with the photogrammetry. Photogrammetry is essentially the process of creating a 3D model from photos. There's a number of software out there that you can use. The most prevalent one that I have found actually practical and useful is a software by Alice Vision, which is called Meshroom. It takes a very simple concept. It's you taking photos of a building instead of measuring it and putting it into the photogrammetry software and then creating a textured 3D mesh out of that. It is slightly complicated in all its steps, but essentially this is 3 steps. You take photos, you put it in the software, you get out a 3D mesh. You can see this image on the right-hand side here. That is a 3D model that I have created from a set of photos. Obviously, this process is not 100% as simple as that, but that is essentially what you need to go. And these kind of 3D models are incredibly detailed. They are millimeter accurate from photos, but it really depends on the quality of the content and how you can utilize that. Alice Vision is the company that creates Meshroom, which is also an open source software. And what that looks like is this. So it's a fairly straightforward user interface. And this is kind of the process that it uses. You can see it's broken into nodes. Anybody who's used Grasshopper or any visual programming tool can recognize the setup. It works from left to right, and it goes through different processes. If we take a set of images, so you can see this set of images. I just took a series of simple, straightforward images. We're looking for like 50% overlap in your images. So you can see it's just different angles of the same thing. And in this, I've taken 270 images. I find that anything from 160 images to 300 is kind of the sweet spot for anything you're doing. What this kind of program likes is a lot of detail, essentially. So anything where it has brickwork or something where it can tell that there's a pattern and there's something to look at, it really likes. Anything where there's a white wall and there's no cracks and it's a very clean architectural white box, it has difficulty with. So I'm going to be upfront that it's not perfect, but it's very powerful. So essentially, you would take all of these photos. So we grab all of these, and then we just drop them into the program, and then it initializes, and it'll drop all of those in there. And you can see it's got this little yellow icon. So here's all the detail that it grabs from that image. So you can see the make of my phone, the focal length, and all of this information. What it prefers is a camera input, essentially. And it thinks that this is medium quality. That's why it's yellow. Essentially, we want it to be green, but even with medium quality, it can create really good results. So anything that is red, it's going to throw out. It says the image is bad. So anything that's blurry or not easy to define. So we can see it's all pretty good. And then what you can do is you click on the node and you can right click it and you can say compute, or you can do these one at a time. So we can say compute there, and it's just asking that we want to save it. So I'm just going to say save, and it's going to compute after I click it. So you can see it already initialized the cameras. Basically, it's already done that. And we can grab each one of these and we can do them one at a time. You can see it's got a little loading bar there, where blue is it hasn't done it yet, and then orange is it's busy with that, and green is it's completed. Unfortunately, to do this entire process, it's going to take 2 hours. So I'm not going to do it live, but I will show the output folder of the 3D mesh. So this is the mesh that comes out of it. And you can see it's recreated a fairly accurate model of the space. This is just from images. and no editing has been done on this mesh, you can see where it has successes and where it has failures. You can see it creates a rough image around the edge. It fails towards the top of the geometry here because I'm a bit too far away and it was obscured. And then you can see along the pipes and the thinner objects, like there's a fence here, it struggles to actually see that geometry. So here it is open in Blender. So this was created just from photos. So I'm just going to go out of the measuring tool, and you can see it is a full 3D model that was created just from images with my phone. And you can see it's adjusted the exposure. That's why some of these bricks are a bit darker than others. But the model we get from this is incredibly accurate. Even with the white wall, which I said it fails at quite often, we get a very detailed 3D model of that space. And the brilliant thing about this is I brought this into Blender. This is the open source 3D modeling tool. It's got a very simple layout, so I'll just go through that quickly. This is the viewport in the center. And then this on the outside is the outliner. Anyone who's familiar with Revit or any 3D modeling program, there's always an outliner. This is just each of these 3D models in a accessible drop down with collections. And then this is the property tab. So we have different properties that we can adjust, formats, views, the world scene, all of that. And then it works just like properties in Revit or AutoCAD. But yeah, so here is the 3D model that's been created from the Photogrammetry. And then if we press 7 on the numpad, you can see in a plan view, it is incredibly accurate. It even includes the depth of the door and where it goes around that space. To begin with, it took me 5 minutes to walk around this space to take photos of this structure. And I didn't need a measuring tape. I didn't need a laser measurer. I took photos, I put it into the software, and I brought it in here. The one thing you do need to do is make sure that you have some sort of scale bar in the photos when you do take this process. Essentially, it doesn't know how big objects are. So for my instance, I measured the opening of the door and I scaled this 3D model to that size. And you can see it's fairly accurate. You can get brick scale and you can get points of interest, even here where there's a masonry line. It's even included some of the foliage, which is not essential here. And it's included things like the slope of the sill and quite a lot of detail. This is just in the textured mode, which is already quite useful. But if you go into the 3D geometry, you can see the actual geometry that was captured there. So we have individual bricks captured in this level of detail. So you could export this and load it into Revit or ArchiCAD and use it as a reference to model existing geometry. But we are going to use it for, or not today, but the idea is that you could use this for building as-built plans and building existing drawings from Blender, essentially. So I'm just going to turn on the measure tool here, and you can see I've got different things measured. And this is exactly as big as they are in real life.
So to summarize,
this is the UI, okay? So this is the whole program, basically. All you need to do is drop some images in here. You can drag and drop them. This is step 1. You drop the images in there. Once those are loaded, and it just makes sure that these little icons are at least yellow or green, basically. That's the only thing you need to check. And then you can say start at the top, and it will do this whole process for you. And it'll do the entire thing. And each step, it's going to tell you whether it's okay or not. 99% of the time, it is perfect, essentially. If your photos are clear and they're not blurry, 99% of the time, it's going to do well. If it doesn't do well, it's going to highlight the photo that is the problem, and it'll ask you to delete it. It'll give you a little pop-up box that says, this photo is a problem, or it'll even discard it automatically. So we would just, you can just click start, and obviously we would just have to save it. But it would go through this whole process. You don't have to even touch it. So step 1 is drop the photos in. Step 2 is click start. Once it's done, you can click on this texturing box at the bottom, and you can say open folder. So it basically automatically creates a folder for you called texturing, right? And inside of this will be a 3D model that you can open in Blender, or you can open in Revit, or you can open anywhere. For photogrammetry, there are a few alternatives. One of them is called ColMap, which gives very similar results. There's another you can use, which is not open source, but just as a point of reference, called Reality Capture. And Reality Capture works on Mac and Windows. And you can see it's actually a tiny bit more complicated than all of them, but it's the same process.
And that's Photogrammetry. 5 seconds of FAQs. If you want to read it, just pause the video.
Moving on to a design concept, and just using some of these tools in Blender. So I'm going to go into slightly more detail with Blender here. Basically an intro. Maybe I should start with the intro next time. But I'm just going to look at the UI, the user interface, to show you where things are again. We're going to use geometry nodes. Anybody who's used, for example, Grasshopper or Dynamo in Revit, geometry nodes are exactly the same. It's a visual programming language. It uses nodes, and it's very straightforward. But I'll show you an example, the twisty tower, this render on the side here, an example of that, and how useful it can be. So I've just got a file here opened up, and this might be a bit confusing at first. So we can adjust the viewports for the scaling for any of these items. We can get rid of them. We can add new ones. So I can click in the corner and I can drag a second one and adjust that in a different way. I don't need that right now, but it's very flexible and it's very performative. So right now I've got a 10-story building here, which is just rotated. You can see there's a little person for scale. And when I select on the person, everything on the left-hand side disappears because this is a modifier, basically. So if we go here to modifier properties, it's kind of an array or something that adjusts the 3D object. So this 3D object is just a cube, you can see over there, with a modifier applied. And that's a geometry nodes modifier. And essentially, these are our nodes, which people who are familiar with Grasshopper or Dynamo will know this immediately, but it's actually quite straightforward. This is a visual programming language. And what it does is it allows us to edit our geometry using written factors. So it's broken into 3 parts here. That's the height. This is the size, and that's the rotation. So you can see I'm taking the height, which is the Z value, and I'm plugging it into the height of the line there. So this is the height of the line, easily adjustable. I'm going to stick with 3. And then we just have the count, which is the number of lines. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the ground floor, which is why I've got it at 0. And then the second portion here is just the cube. These are the dimensions of the floor here, which are these elements. So we can take the floor and we can make it wider. We can make it thinner in multiple directions. And we can make it taller and shorter. And I'm just going to stick to my base values here. I'm going to go back to our elevation view. And then this bottom element is just the rotation. And essentially, we're just creating an angle that we can rotate this tower on. So once this is set up, right, that's the height. This is the size, and that's the rotation. Once this is set up, you can forget about this. That can go away. And we can just look at the 3D model. So that's how it works slightly differently from Grasshopper or Dynamo. And then we can just mess with the values here. We can make the number of floors infinitely high. So if I go back to my elevation view, this is just a 10-story building. And we could quite easily make that a 50-story, or we can make it a 100-story. Or if we want this to be the size of the Burj Khalifa, we could say make that 160. And we can make the floor heights 4 meters. Or if we want to be ridiculous, and we can zoom all the way out. Sorry, I don't know if you can even see the line anymore, but we can make this a 10,000 floor building. And you can see how performative this is, in that it's still performing fairly well. And I'm not having any lag on this building that is nearly infinitely tall. So anybody who knows doing this exact same thing in Dynamo or Grasshopper is impossible, essentially. A 10,000 story building will crash or at least freeze most computers. So Sorry, excuse me. So this is a very powerful tool and is very performative. It is very fast. It's very efficient. And then we can rotate and change this on the fly. It doesn't lag. We can create multiple copies of this. So I'm just going to bring it back down. Well, we'll leave it at 10,000. We're going to create an array, which is another modifier. I'm going to collapse the geometry nodes one. And I'm going to say I want it to move along the x-axis. And then I'm going to create another array. And I want that to move along the y-axis. So now we have 4 of these buildings. So we can put this count way up. Make it 74. You can see I'm starting to get a bit of lag there. Made it 270, or there we go, 120, 124. 124 10,000 story buildings. It's very performative. It runs on much older hardware than Revit or ArchiCAD or even SketchUp. And the size of models it can use are very, very big. So I'm just going to get rid of my arrays and get back to our normal building. Go back to the elevation. See, my screencast keys have disappeared there. My bad. And then if we come back here, we can just bring this back to 100 or maybe 10. I think let's head up. And you can see we can just adjust it freeform. It's very performative. It's very useful. So what we can get out of this is basically basic massing for a skyscraper or a multi-story building, as an example. What we can get out of this is we can use another tool to turn this into a real building, essentially, or any massing structure into a real building. So if we're done with the geometry nodes, I'm just going to open another file, and I'm just going to demonstrate one of the other tools that we're using. I'm just going to do a short plan using BlenderBim. And then here I was mentioning that in the 3-day workshop, we are going to do each stage. So I will do to a level of council drawings. And we're just going to do some documentation. I'm going to show you how to do some very basic modeling in BlenderBim and how to do that same kind of modeling in native Blender, and then how we can get some 2D drawings out of it, some very simple ones. It's not a full tutorial, but it's definitely everything you need to get going. So the reason I wanted to start this CPD to get people to introduced to this is because BlenderBim is quite a powerful documentation tool. It takes an IFC file, which is, as I mentioned, an international standard, which means any AEC, architecture, engineering, construction program can open an IFC file, which means whatever you make can be transferred, at least the geometry, to another program. So if you're coordinating with engineers, or if you're coordinating with other architects who use different programs, it's much easier if that's in IFC than in a native Revit, ArchiCAD, Rhino file. So I essentially started by making some tutorials online to get people introduced to this, starting with this very simple floor plan that we are going to be recreating. And I've done a whole bunch of tutorials, which are step-by-step walking through modeling, drafting, section elevation. These are very, very simple though, and they're not hooked to the stages, but they're available for free, and then just simple layouts. And I've used this tool on multiple occasions to do council submission documentation. So here we just got line weights and hatch patterns. And then here we have an example of council submission. So BlenderBim is completely capable of creating these kinds of drawings. What I'd recommend at this stage, being realistic about it, is that anybody who currently uses a software to create documentation for small to medium-sized residential projects, that's probably the ideal use case. It can be used for much larger projects, but the only downside is that it's not as stable as a Revit or a ArchiCAD. But on the upside is I've never had a crash with BlenderBim. I've never had lag with BlenderBim. I don't wait 20 minutes for the file to open to start my day. And most of the time I just get into it and I start documenting. So I'm going to show that process with a new project, a very simple one. And you can see just here, this is just an example of the kind of drafting you can do. It can do anything, it can look like anything. It just requires a level of intellect and knowledge about the program. So if you want to follow what I'm doing, you can see everything here in the bottom left. We are going to say create project. It's going to have an IFC4 schema, metric, millimeters, cube, and square meters. And then make sure you select the IFC4 demo library. We are going to use the IFC4 AU library later, but we're going to start with the demo library. So I'm going to say create project. And then you can see it's loaded the project on the side. So this is the project layout. And then we've got the types list over here. And then if we just view that, we can see all the types that have been added to the file. So we're just going to hide that again. We're going to collapse that because we don't need it. And then we're going to press N on the keyboard. And we're going to go to the tool bar. And we're going to go to the BIM tool. Then from here, we're just going to go and select the wall type. And we're going to start with a 200 wall. We're going to do the external walls first. So I'm going to press 7 on my numpad to orient to plan view. In Blender, the Y is the north-south axis and the X is the east-west axis, essentially. So we're going to start with that, and I already know how long I want this to be. So I'm going to add it over here by just pressing Shift-A, and then I'm going to change the length to 10,000 millimeters, which is 10 meters, 10, 1, 2, 3, enter, and then just hit refresh, and it'll add it there. And then go to the next one, and then I know exactly how long I want this to be. I'm going to say 3,000, and I'm going to say Shift-A, and then I want the next one to be 1,500. I'm going to say Shift-A, Shift-R to rotate it. And then the next one I want to be 4,000. Say Shift-A, Shift-R. And then the next one I want to be 4,000 again. Shift-A, Shift-R. And then I want this one to be 5,000. 5,000. Shift-A. And then Shift-A. I want this one to be 6,000. So I'm just going to say refresh. Let me say Shift-A, Shift-F to flip it so it's in the right orientation there for me. Shift-E, Shift-A, Shift-F, Shift-E. And that's our external walls. Very nice, very simple. We're going to move on to our internal ones. So I'm just going to snap to the cuts that we created earlier. I'm going to change this to a 100. And I'm just going to say, I know I want this to be 3,000 long. And then I'm just going to say Shift-A. And then I'm not actually going to add a whole bunch of walls. I'm just going to select this one and say Shift-D-Y. And then just snap it to where those breaks are. And then I'm going to extend this one, Shift-E, I'm going to say Shift-A, I'm going to say Shift-F to flip it, Shift-E to snap it there. I'm going to grab this guy, and I'm going to say Shift-E so to bring him in. So now we have our external and internal. The next thing we want to do is add a camera. So if we go to BIM documentation, we see this is one of the first things that's changed. Here it won't allow you to create a drawing, a sheet, or a schedule without saving the project first. So essentially how the sheets reference how it works has changed, and now all the sheets and drawings are saved locally instead of your BlenderBim folder. So that now you can have a whole huge set of sheets and drawings with each project, which makes it much better, to be honest. So you can either say save project here, or you can go to your scene properties and save the project here. So we're just going to say save project, and I'm just going to put it where I have this project. So I'm going to call it tutorial floor plan redo. I'm going to say export, and then you can see it's been saved. And then we can go and create a drawing. So we're going to create a plan drawing that is at the my story, which is the 1 meter high default. So we're going to say add drawing, and then you can see it's added a camera. So if we want to go into this camera, all we have to do is activate it. And then you can see something slightly different. So it's cut this view, and then it's also created a preview for us what the 2D cut is going to look like. So if I go into 3D, you can see it's actually shown us the preview at the correct height, which is quite nice. It brings you closer from the AutoCAD process to a what you see is what you get process. So I'm going to go back, I'm going to press Naught, I'm going to select the camera, and I'm going to actually adjust it by going to Object Data Properties. And in the orthographic camera, I'm going to say 15 to bring it in, and then I'm just going to turn off my snaps temporarily. I'm going to press G so I can center this a little bit, and then turn my snaps back on. Quite important. You can see the camera has been added here to the views on the side there, and we've got a fairly good preview here. So what we're going to do is we're just going to activate it again, and we're just going to say create drawing. And then you can see we've got a nice external internal wall drawing. So I'm going to close that, and we're going to move on to doors. I'm going to say tool, change this to door type. Make sure you have your BIM tool selected. And we're just going to create some doors. So I'm going to say Shift-A. I'm just going to snap basically to the centers of where I want these things. So we're going to go there. I'm going to say Shift-A. And then over there, I'm going to say Shift A, and over here, I'm going to say Shift A. And then I'm just going to grab this guy, GX, Shift G to regenerate the position, Shift A. I want this to be against the edge, GX, Shift G. Okay, cool. And now we're going to get the next cool part of the updates. So in BIM documentation, when we say activate view drawing, it's going to show us the door swing. It's going to show us a 2D representation of that object. So I want to change the swing of these doors so that they're facing the other direction because I don't like the direction it's facing right now. So instead of editing the 2D representation, we're going to go and use a new tool. I'm going to go to the modifiers, and you can see all these modifiers that have been added since the first time I did this tutorial. And we are going to say IFC door, we're going to say add, and then we're going to edit it. So you can see it's changed it to a single swing left where it was a right hand swing. So this is already what I want, but I also want to change the height to 2100, or not 21,000, and then also the width to 800, which I think is just more reasonable. And then I'm just going to say finish editing. Since these are all the same type, they have been edited as well. And then, oh, you can see that we've accidentally moved all our doors outside. So we're going to select them all, and we're going to go to our object properties. I'm going to collapse all this, go to the object, IFC object metadata, collapse that, go to the spatial container, and then open that. And we are going to go into our building and into our story. We're going to select that, and we're going to say assign container. And this is the correct way to move these objects back into the correct container. Anyway, now that we've done that, we can just say activate drawing. And then you can see it's changed the swing of these doors. So this guy, you can see, is still facing the wrong direction. And we don't want to flip him in the 2D view because it flips on the center of the 2D. So if we say flip, it flips it incorrectly. But we can just simply change it back. We can close this. We can go to geometry, go to our representations, change to our model view, select that one, say Shift F. And then a simple way to tell in the model view is that whichever direction the door is facing, that is the direction it's opening, essentially. So then we can just activate the drawing again, and you can see it's changed the door flip direction there. Okay, cool. So now we can do our windows. Go Tool, we can go to Window Type, and then I'm just going to add it to the centers. Remember to select the wall first, and then add the object you want to add. So I'm going to say Shift A, select the wall, Shift A, select the wall, Shift A, select the wall. I'm just going to add it there, Shift A, select the wall, one there, and one there, and then one there, and add two here, Shift A, Shift A, and then we're going to add two here, Shift A, and Shift A. And then these two I want to be on the outside again, so I'm just going to select them, say GY, and snap them to the top, and there it's sorted. So then we can just go to BIM documentation, we can activate again, and you can see it's changed to the 2D representation of the windows as well, and we can say create drawing. And there you can see we've got door swings and the windows in. Okay, the next thing we want to do is add our furnishing elements and just fill up the scene. So we're not going to use a custom file this time, we're going to use the IFC4AU demo file. So go over here to our scene properties, IFC project setup, and you can download this in the description. It does come with BlenderBim. It's located in your data folder, but you can download it in the description. Make sure you're using the latest version. Go to IFC project library, click on this file icon, and then just navigate to where you have it downloaded. So I've got it in my library, and select the IFC4AU library, select that library file, and then we're just going to expand this and scroll it down because there's quite a few. Expand it all the way, and then we're going to IFC type project, and then we're going to IFC furniture type. So we're just going to select a few of them. The first one we want is the 1-seater sofa, then the 2-seater sofa, then I think we want the large sink, and we're just going to scroll down here. We don't want the toilet without the cistern. We want the king bed. I think we're going for the biggest cooktop here. We want a medium basin. There we go. I don't think we're going to use a urinal this time. We're going to go with a 5-seater circular table and a 6-seater rectangular table. I think we're going to go with a 75 by 90 shower. And we're going to go with a, let's have a look, toilet with cistern. And I think that's everything we wanted. Not a lot.
Then it's quite simple. We can go into Tool, we can go into our furniture type, and you can see these have been added to the bunny. So we're going to start with the generic 1-seater sofa. And again, you can see I've got these in the wrong space, so I'm just going to select them all. I'm going to go to the object properties. We're going to go to object metadata, go to the IFC spatial container, go in here to the My Story and say assign container, and then just make sure, the mistake I keep making, just make sure you select the correct folder when you add these items. Okay, cool. So furniture. So we're going to start with this generic furniture set. Let's say Shift A. And now we can't really see what's happening. So normally we'd switch over to 2D representation, but you know now that has automatically happened. So we can say activate drawing, and there it is. So I can just rotate this. So it's roughly like that. I'm going to say G and move it there. I'm going to say Shift D X, rotate it in the other direction, GX, and there it is. And now we're going to add the next one, which is the 2-seater, Shift A. Again, we can activate it to see which direction it is in. Rotate Z 180, because it needs to face the other direction, and put it there. And then we can go to the next one. Well, let's select it from here, right? We can use the generic large sink. We're going to put it underneath the window. We're going to say Shift A. We can go here. We can say Activate View. We can bring it up here. You can see where the tab position is. So I'm going to rotate it Z 180, and then just snap it underneath that window, basically. And then we can use the toilet without system. We can snap it to the center here. We say Shift A. This one we can tell which direction it's going. Rotate Z 180. Perfect. And then we can go with the cooktop. We can go there, Shift A. Let's activate the view so we can see it. There it is. G, G, GY. Bring it down by 50, minus 50. We're going to go here again, get our medium basin, say Shift A, activate the view, select that basin, rotate Z 180. We're going to go with our shower, I think. Let's go Shift A, activate the view, rotate Z minus 90, and just snap it into the correct position. Go with our, did I add the toilet with the system? Let's go with our 6-seater rectangular table. We're just going to say Shift A. That one we don't really need to preview. And then 5-seater circular table, Shift A. And then let's do the, did I not add the king bed? Let's go Tool. I didn't. Okay. I'm going to go into our project. And then we're going to scroll down to the king bed. Whoops, I added the generic toilet. There we go. King bed. There, we're just going to say Shift A. I'm going to activate the view, and then adjust it. And then just say Shift D, rotate Z, minus 90. And just snap it there. Okay, cool. Now we've got basically all of our 2D elements in there. And we're just going to go and just check what that looks like in preview. We can activate the drawing. We're going to say Create Drawing. And there we go. Next thing we're going to do is we're just going to draw in the countertops with the line tool again. So now we have an annotation tool, which is just similar to the BIM tool. It creates a drop down over here, but the tools are also still here. So we can just go with the, let's go line tool, and we're just going to say Shift A to add the annotation. We can bring it here, and then we can take this guy and say GY, bring it there, GY minus 600. We can say EX, bring it to the end, GX minus 900. EY, and then we can select 2, which is for the edges, and we can select that edge, and we say Shift DX, and we can say 50, and then we can say EX 800, and then we can select these, and we can say X, and delete only the faces, and then we're left with the outline. Then we can select these guys as well. Select 2, select just this guy, I think, or both of these guys. Shift D and then Y, bring it down, bring down GY so that it lines up there, and then select 2, select this guy, GY 1 to 100, press 1, bring it across, and there we've got a countertop. So now we can do the built-in cupboards here. Just select this guy again and say Shift DY, snap it there, and then select these edges and snap it to the inside there. grab the skin, Shift DY, GY, there's some built-in cupboards tab, and that's all the 2D stuff we want to do for that. In this case, we're not going to add a TV, we're just going to draw it in 2D, so I'm going to tab back into there. I'm going to select this line, Shift D, and put it over here, just about there. I'm going to press 1, and I'm going to snap it there to see how long it is, -2,900, so I'm going to say -1,400, so we can have 1,500. I'm going to press 2, and then I'm going to say EY, let's see, -200 for the width. Then I'm going to select these guys, I'm going to say X, only faces, then I'm going to select 2 again, select one of these, Shift D, Y, -100, and then I'm just going to scale it in roughly so that I can see it. Okay, and then tab out of it, and then we can just activate the drawing again, and we can say create drawing, and there we can see our TV's been added. Maybe we just want to center it. Just going to tab back in there, grab these, and then just say G, so that's centered, and then maybe grab these guys and move them a bit closer as well. G, Y, there we go. Activate and print. Okay, cool. The last thing we want to do is add the trees. This is going to be a custom family. You can download it in the description. So go back to our file, and then we're going to go and wherever you've downloaded it, just go get it. I've got it here in my standards, my nature, and it's called small tree update. So we select that file, type product, building element, and then we just say add pinned element, and then we go to tool, make sure we are in the BIM tool, make sure we have got this file selected. We're going to go to building element proxy type, and I'm going to select the tree, and then we're going to basically add it in the same position, say Shift A. If you want to see its 2D view, we can just activate it, grab that, say Shift D about there, and then say Shift D about there. Okay, cool, and that's roughly the same thing. Activate the view and create the drawing. And there we go, we've recreated this floor plan in the most up-to-date way. I hope that was insightful, and I hope that was helpful.
5 seconds of FAQs. If you want to read it, just pause the video.
Okay, presentation. Blender is primarily a 3D modeling and animation tool, so it is incredibly good at simple presentation and video presentations, animation tool, so it's made for videos. So I'm going to do another kind of example showing how we can quickly create a model and just set it up using the model I just created with BlenderBim. This 30-minute one is just a very basic one. It's not mind-blowing, but it just shows you how quickly you can get to a result. So I'm going to start with just showing some example renders. So this is that twisty tower with some lighting and some very basic shadows, and then giving it an outliner and adjusting that and changing up the shadows essentially. And then this is a model of the city of Johannesburg that has been given a wood texture to look like a hand-built model. Essentially, this is a render from Blender, and with a conceptual twisty tower in the center there. And it's just to show an example of what you can do. So I'm going to show how we can get to it. So this is the 3D model that we have as the IFC. And basically what we did is we broke the IFC. And from here on, I'm just using normal Blender modeling. So same thing, I'm grabbing the edge and I'm pulling it to the side there. So I'm just going to model essentially the context of the house, the porch, the edges on the grass and the boundary walls, and then get through the different elements. So in this case, I didn't do a floor slab, so I'm just modeling it in Blender instead of using the BlenderBim's parametric modeling tools. And you can see it's quite straightforward. I'm just extruding things like in SketchUp. It's very simple. Basically, any workflow you have in SketchUp or Revit can be mimicked in Blender. It just requires getting to a level of understanding with Blender. Here you can see I'm just adjusting this porch portion here. just making it a certain size and then adjusting. So I'm just pulling and pushing edges here and making a Porsche that is higher. I think I bring it down by a step. So I just say -85, which is like half a step. And then I snap the 3D geometry. Here's just an example, like the geometry of the furniture and the finishing elements is very simple. So it stays very performative. And you can replace those with more detailed elements later on, but it tends to stay very effective. So here I'm just mocking out a driveway, making it 5x3. And then just duplicating it and using that same geometry to create the grass area. So I'm just offsetting elements, making wraparound a grass floor. And obviously this imaginary site is very flat. In a real world, we'd probably have a slope, but just for this instance, it's just going to be flat. So basically extruding these edges and snapping them to different things. So I'm not measuring anything. I'm just snapping and extruding, which is very simple. Like this is happening in real time. And I'm just using the built-in tools of Blender for the representation here. None of this is BlenderBim. All of this is Blender. So we're just using the model we created with BlenderBim, which is an IFC model. And now that we're using Blender natively, this is no longer an IFC model. It's just a blend file, which is Blender's native file format. So here I'm just creating the boundary wall. I'm using a plane to extrude it, and I'm just snapping it to the edges and constraining it. It's very quick. So I just left the front of the house open. And essentially the end goal of this is just to create a render from the courtyard side demonstrating what this needs to look like. So it's just a bunch of planes essentially so far. And then here I'm going into, so now the modeling portion is done. It's a very basic model. The layout is actually based on a Burkhardt house, but obviously it doesn't look anything like it here. And here I'm just adding a sun, basically. So this is going to be our light source. And I'm enabling some shadows, and I'm changing the mode from a 2D mode, just like Revit has different modes, to a shaded mode, essentially. So there you can see basic shadows. And here I'm using an add-on called Sun Position, which just allows me to give it Johannesburg coordinates, essentially. The one thing it messes up is the southern the longitude, the latitude, sorry. So there you can see the sun, it's in the correct position, and it's giving us correct shadows, basically. This obviously doesn't look so good yet, so far, but then this is where the built-in assets with Blender really help out. So we can move on to materials here, and I switch to material mode, so we're getting rid of the shadows. And just going very straightforward, it's a very simple process, drag and drop, and you can start texturing the model itself. So there's the grass. I use some pavers for the driveway. Different pavers for the the entrance stoop there. And then I think I move on to the walls. Yeah, I'm going to the bricks and then just choosing. So you can see it's a bit skew there. Sometimes you just need to reset things in Blender. So easily fixed. Blender gives you a lot of control with what you're doing. And sometimes that can be overwhelming. But you can see just from this process that it's very straightforward. And I've set up all my assets so that the bricks are the right scale. When I put something down, it's as it should be in real life. So I'm just quickly texturing this entire space. You can see because these are separate walls, they need to be textured separately. And then you can see the texture is just being stretched. Again, we're just going to select it. And basically we need to apply the transforms that I've made to it. It's just like the modifiers, I've made some transforms. So we just apply those transforms and everything gets fixed. And then the roof, we just need a roof tile. Snap it, looks excellent. And then for this outside space, I think I probably just use a grass paver again. Or a wood. I think a wood works out better. Well, we try a grass paver, which looks okay. But this is just a simple set of pre-built textures that I have. And will be distributed at the 3-day course. But essentially, you can set this up by taking a photo of a parquet floor, and you can create your own texture. So here I've actually set on the wood. It's already built in correctly, and everything is aligning. I think I just want to get rid of the floor because it's getting in the way, which is just the grid layout for reference. And then just wanting to texture the floor there on the inside. So I just hid the roof there so I could see the inside. And I selected just the faces that I wanted that texture to be on. So I separated that part of the floor from the outside part. So I can just drag in a wood floor. And you can see I've accidentally selected 2 there, but dragged in a herringbone pattern wood floor. And then a separate texture for the portions of the slab that's exposed to the outside. So here I actually use a way to link materials. You just select both and you say link materials. So anything that's has a material will override something that doesn't. And then we just have the bricks wrapping around all the way. And that's some very basic texturing. And then just the glass. There's 100 different glasses in Blender, but all of them work very well. So just drag and drop and the glass comes through. It's a very simple workflow, which I think I can actually speed through a tiny bit. Yeah, and then the same thing for the doors. I wanted a wood texture. I don't think I like that one. And yeah, went with a darker wood. Yeah. And then simply enough. Let's go. And then here I'm just separating the chairs from the table, basically, so they can have separate textures. And I also wanted the tabletop to have separate texture from the base. So simple again, drag and drop the textures. It's really a very clean interface, and it works really well. So here I'm just using a white texture for the chairs. It has a bit of a grain to it, so it'll catch that in the light, basically. And then using a bevel modifier gives it a kind of soft edge, basically. And then I think I replace the trees with some proper nature. So again, it's quite simple, drag and drop. I think this tree doesn't have any leaves. It's like a winter tree, so I do delete it. But there's the tree I settle on, and I just scale it down because I don't want something that big. And then I just duplicate that tree and align it with those placeholders. So you can really see it's kind of using Blender for what it's good at and using BlenderBim for what it's good at. So BlenderBim gives us the geometry, it keeps us parametric, it gives us the drawings, and that becomes interchangeable with any format. And then if we want to do rendering work, if we want to do presentation work, we can just take that geometry and continue to use it in Blender natively, and then bring it in with textures, foliage, lighting, all of these elements. So here I'm just scaling and rotating the trees so they look a bit more random. And then here I'm just adding a camera so we can set up our shot. So basically I'm just using it as like a first-person camera, the walk navigation. So wherever my mouse points, it goes. And then I'm controlling it with the WASD keys on the keyboard. And I'm just lining it up. I think I take a bit too long to actually choose a view. But this is basically what I set on. That's the focal length of the camera there. In SketchUp, the default of the focal length is 30 millimeters, I think. Yeah, and then this is what I set on, essentially. So that's the view, that's lined up. And then I didn't like that tree, so I think I didn't like the texture on the wood. So I think I changed it for like a mossy wood. So you can edit these different elements. It gives you a lot of control. And then I think the leaf textures as well, I thought were just a bit too plain. So I give them a grass texture to just be a bit more realistic. And I drop this. I think I settle on removing that middle tree because it's just in the way of the view. Okay, so here we just transition to the rendered shaded view, and then Blender essentially, I'm just going to pause it for a second, has two renderers. One is called Eevee, which is similar to Lumion. It's a real-time renderer, which means what you see is what you get. Like you can take a screenshot of your viewport and it will look like that. And the other one is Cycles, which is a ray traced render. If you want accurate shadows, reflections, all of that, Cycles is the thing that will check where the light is going and calculate it correctly. Eevee is kind of a game engine. It guesses what the lighting should look like. It's very close, so you can definitely use it, but Cycles is the more accurate one. So I'm shifting to Cycles here, and you can see I just turned on denoising because what it does is it creates a point cloud, essentially, of what these things need to look like. So it looks okay at a glance. I think there's a few things I want to change. I wanted to change that wall to like a paper texture, which is like a very nice, soft, plaster looking texture, just so we get a bit more light. And that wraparound brick at the bottom there as well. And then I think I decide here just to add a few plants and some elements in there. You can see it's quite easy. Now that we've chosen the viewports, we can start to get a lot more detail. And things are easy enough to edit and navigate. And you can see it's rendering basically in real time. I'm not waiting for things to update. I can adjust them and put them where I want to and see the effect nearly instantly. So there I'm just adding the grass essentially. So I selected the grass plane, and it's a fur material, but it looks exactly like grass. It's used for the same elements. Basically, it gives you a set of modifiers that you can edit. So you can make tall grass or short grass or anything. But this is basically quick grass, basically. So you can just get a quick effect and it can look good. There are ways to do more detailed things. You can add flowers, you can add instances of things, but just for the purposes of this quick demo of just showing how you can get some sort of visualization out. So again, it's just some more scene dressing and some adjustment of that, scaling of objects, and just adjusting the render. And then I decided this pot plant needed to be on the table, which actually didn't look too good, but that's how these elements work. And here I give the trees a grass texture. So there's a lot of ways to change it out. So a quick way to do this was probably just to select all the trees and link the materials like I showed with the brick wall earlier. But sometimes you don't think about these things. Yeah. And then I wanted to add some ivy. So there's a lot of built-in add-ons like the ivy generator, which allows you to generate some ivy. It's quite simple, gives you a panel to create this, and it just creates a very simple ivy element there. So I wasn't quite happy with that, so changed the seed, which is just like the randomness of the elements, and then how long it can go, making it much bigger, just so that it has a bit more visibility. And just making everything a tiny bit bigger. And then it gave me something that I was quite a little bit happier with. I just brought it down, and then I think I settled on that one. Yeah. So then I shifted back to rendered mode. You can see it's looking a bit good. The ivy doesn't have a texture, so we just had to apply one. And I just selected the same textures as the tree. And then here it just comes to some editing of the world environment. So just a quick reference into this. There are multiple ways to do shading of your environments in Blender. You can use a sun, which gives you like an accurate position according to a longitude and a latitude, or you can use a 360-degree photo called an HDRI, which is often used in animation and visual effects. But until Blender, I had not seen it used in architecture. But what that gives you is two things. The one thing is it gives you a 360-degree photo of a surrounding, a context, which is very useful, especially when we do renders for a house. And the other thing is it gives you the lighting of that photo, which means if you have something reflective in your environment, it will bounce the light from that photo. So if it's a forest scene, you will get green bounce light. So it's more realistic than just going with a blank sun that is a yellow color. It actually bounces the environment. So here I'm just selecting one called Autumn Park. These are available for free, the HDRIs, the 360-degree photos. And you can see there's a tree in the background now, and it's giving us a bit more lighting. It might not seem too different, but you can definitely see the difference. So here I'm just rendering out the image. I could have just taken a screenshot. It looks basically identical. But I'm rendering out the image just to show how long it takes. And you can set these values differently. You can see already it looks quite good. It's a tiny bit noisy. But yeah, I decided that tree was getting in the way, and I definitely think it looks better without it. And I think I just wanted to add a tiny bit more ivy, but it didn't really work out. Well, there we go. Yeah. And then I just linked the materials so that we got a tiny bit more randomness. Unfortunately, we got a bit of a tangent between the pot plant and the ivy itself, so the pot plant gets a bit lost. But following that, we just re-rendered the file. I set a time limit to the render so that it doesn't take 100 years. I set a 30-second time limit, which it's a level of control that you can get that you can't do in other programs. Basically, Blender will do the best it can. But if you say, I only want this to render for 30 seconds, it'll be like, I'll do my best for 30 seconds and give you what it is. And 90% of the time, that is a pretty good result. So this is basically it. It's an okay result, but it is only 30 minutes of setting up. If we had more time to look at the camera, maybe adjust it to be more architectural, maybe push the trees to the boundary and look at the detailing. This house was not designed. It was just a tutorial. We could definitely bring these up. But the point is you get to a point where it's more about the architecture and what you're trying to design than it is about the program. The program is not getting in the way of you visualizing what you need.
5 seconds of FAQs. If you want to read it, just pause the video.
Okay, the one that is like the permeated thing in the background of everything I've shown you, the cost and the comparison of that. You got to think about this in a comprehensive way. Everything I've shown you is free and open source, so you can use it forever, and no one will charge you a cent because it doesn't belong to anybody. And it really doesn't compare. If you look at like an architectural workflow and the performance and storage differences, which I'll show you in a minute, there's advantages to this that haven't even been apparent until now. So I've just got this little table here showing some proprietary, which means private software, and open source. And at the top, I've just got a list of all the kinds of software we use in architecture. There's Revit, Twinmotion, Lumion, those are rendering software, SketchUp, I would consider like a design modeling software, ArchiCAD, Rhino, and Adobe Suite. And a lot of these softwares have moved from a once-off cost to a yearly subscription model, which some people don't mind. I think some of them are very reasonable and very cheap. Like SketchUp is still worth its money, and so is Rhino. But the point is, at any point in the future, they could decide that they want to change to a subscription model, which means that you will be paying per user per year every year for the rest of time. Lumion recently changed from a once-off fee to a subscription model. They're busy working it out, what they want to charge. But if you compare that to Blender or all of the software I've shown you until now, completely free. So if you look at the bottom table, you can see an example of a workflow cost. looking at concept, documentation, rendering, and presentation. And you can look at the total cost of a single user. And I know in Architecture Office, we share the software and everything. It doesn't really work out per user. But in a big firm or anything larger than 5 people, you do need separate softwares because people need to work on the same things at the same time. And it kind of can work out to about 100,000 Rand per person. And that could easily be a per year cost. And then if you look on the right-hand side, which are just open source equivalents, free and open source equivalents, Blender, BlenderBim, Cycles and Eevee, which are those 2 rendering engines I mentioned. And then these set of tools, GIMP, Krita, these are Photoshop equivalents. Krita is incredible. It's my favorite one. GIMP is a bit more powerful, but it's harder to use. Inkscape is Illustrator. It's identical. It's basically the same thing. It's just a tiny bit harder to use. Blender itself is also a presentation tool. I do all my video editing in Blender as well. And then LibreOffice and Scribus. Scribus is essentially InDesign. It's the only one of these software where I'd say InDesign is better. But Scribus does exactly the same stuff. Even the presentation I'm using now is not PowerPoint. It is part of LibreOffice. So LibreOffice does everything Microsoft Office does for free locally. So it doesn't have to be in the cloud. I'd say this is just one of those instances where look at whether it's applicable to you. It uses Microsoft Word documents. It uses all the same formats, but it's free. So if that's a cost to you, or if you are using Google Sheets and Google Docs and all that kind of thing, that's also applicable. The only difference is Google Docs is not open source. Obviously, it's restricted to your usage of that service. But LibreOffice has all the tools you need. It has a Word format. It has an Excel equivalent, all of that. And I use it every single day. And I haven't used Microsoft Office this is probably the oldest software I've used, open source software. I haven't used Microsoft Office for probably 7 years, just because it's annoying to updates and licenses and that kind of thing. But yeah, so it's one example of if it's applicable to you, this is where you can use it. But like all of these tools, this is just, if you see something that's useful, then try it out. But yeah, this is kind of what I want you to walk away from this with, which is the rate it's going to cost more to operate an Architecture Office using these other tools. And open source software, free software, is kind of completely the opposite alignment of that. It's becoming better, it's becoming faster, it's becoming more performative. So besides the cost comparison, right, where in a large firm, this can cost you quite a lot of money, or in a small firm even, like who has an extra 100,000 to spare when you could be paying staff or buying equipment or doing something else. Another big example, which is a difference, is the file sizes. So this council submission drawing over here, if you had to do this in, let's say, Revit, and get the same level of detail and the same kind of drawings, this file could range between 5 gigabytes and 15 gigabytes, depending on your level of detail, but just to the council submission stage. Now, this exact drawing, this exact file, I have here in my folder, and you can see the size over there. This file is 3.5 megabytes. That's how efficient this format is. So out of a 3.5 megabyte file, you can get a full set of council submission drawings, you can get a full 3D model, and all of the information attached to that. So just think about it in regards to storage. If you got 5 gigabytes per project, or you have 3 megabytes per project. I would say on average, depending on this is just the file up to the council submission stage. When I did construction drawing stage, it got up to a whopping 7 megabytes. So, you do have to be careful there, but it's just much more efficient in regards to cost, in regards to space. If you think about storage, for instance, when I was doing this documentation set, I didn't delete any version. I still have a full backup of every single day I worked up on this file. And all of that altogether only adds up to 700 megabytes. So it's a no-brainer to me. So yeah, this file is 3.5 megabytes. And you can see the example, the demo file I made earlier. You can see that one is 230 kilobytes. So just have a think about it. There's a reason these files are so efficient and that they're so performative. It's because they take out stuff like it's called DRM, digital rights management. It's the stuff that checks whether your software is legal. There's stuff like built-in libraries, and a lot of that stuff is loaded on automatically. BlenderBim and 1hr40mins is just so incredibly efficient because it doesn't have all of that extra stuff. So just think about it, compare it, see for yourself. So have a look.
5 seconds of FAQs. If you want to read it, just pause the video.
So AI image generation. I'm sure some of you have heard of DALL-E, which is the initial AI image generator from OpenAI, which is the company that made ChatGPT and GPT-4. There have been several AI image generators after that. A very popular one is called Midjourney, especially amongst architects. And there's several others. There's many copycats that are all very, very good. Midjourney is excellent. But today I'm going to be discussing Stable Diffusion, which is an open source equivalent. And it is also excellent, maybe not as good as Midjourney. It is better than DALL-E for sure. And just 3 ways that you could use it in your workflow that I've found that's quite useful. There's obviously controversy around these kind of AI image generators because of the data sets that they're trained on, whether they are copyrighted and anything along those lines. I would say if you ever use these tools, attribute the fact that it was created partially or completely using AI image generation. On the other hand, there are data sets that are trained on like Wikicommons imagery, which are open source as well, but they're not so useful at the moment. So it's just something to consider if you're going to use it. But I found 3 ways where I feel like it's authentic to use and is actually helpful to our process as architects. So the 3 ways are using a concept workflow where you just generate an idea from a description. That's probably the least managed way, which is the way most people use it. The second one is to use a sketch to translate that into a render. And the third one is actually just to improve the final presentation of your render, like this kind of example I've got here, which is the same render we made, but run through Stable Diffusion to create an enhanced version, essentially. These tools are not perfect, but for the most part, it tends to look pretty good. And in some cases, it can just give you hints on how to improve your render natively instead of running it through an image generator.
Okay, so you're going to go to where you have Stable Diffusion saved, installed. We're going to go into it. We're going to go into our Stable Diffusion web UI, and then we scroll down to the web user bat. We double click that. It loads the command window, and then we just wait for this to run through all of its requirements. And once this is done, it's going to give us a URL. That URL we're going to take and then just copy into our browser. And then we're just going to check it from there. So here's the URL. So I'm just going to click in there and highlight it and say Control-C for copy. I'm going to open my browser. I'm going to paste it. And there it loads the user interface. This is the model I'm going to be using today, the Arc multi-prompt. It's an architecture model. And we want to do image to image. And we want to do a sketch, basically. So get those set. Then I'm just going to take a sketch that I've done. It's a simple one of a house, staggering with butterfly roofs, staggering up a hill. It's very simple. I've got a little person there for scale. And I'm just going to drag and drop it in there. And then we just want to make sure that this width and height matches the ratio of this drawing. So my ratio is 1153 by 604. Okay. And then with this denoise strength, basically, the closer this is to 0, you're just going to get the results that you put in out. The closest this is to 1, you're going to get a more creative result. So if I show you some examples, I'm going to just put in the prompt first. Here's the prompt I want to use. It's a house on a lush green landscape surrounded by trees, modern architecture, house concept, photoreal, morning, blue sky rendered in Lumion. That's it. I'm not going to use negative prompts right now, and I'm not going to use any of the styles. So here we're just using the Stable Diffusion model. So I just want you to see what that looks like with this set to 1, which is the most creative. Basically, it gets to do whatever it wants with the image. So we say generate, and then we wait a little while. You can see it says a minute, but then it immediately jumps down. So it's just busy generating the image. And there, it's created something very beautiful, but very different from what we want. Let's just wait for it to end. And we can click on it, and it's stunning. So I'm just going to save that. It's stunning, but it's not what we want. So you can see that's the most creative it can be. And then if I bring this down to like 0.5 and I say generate, you can see it basically looks like the sketch, but it's changed it. So it's less creative. So that's kind of your sliding scale. What we're going to do is we're going to use an add-on to Stable Diffusion called ControlNet, which allows us to preserve the shape, but still allow for that creativity. So I'm going to bring this back to 1, and I'm going to come down here to ControlNet and open that up. I'm just going to say enable, and then I'm going to select with the pre-processor. I'm going to select Canny, which it outlines that very well. And then with the model, I'm going to use this MLSD, which is also an architectural model. We're going to go here. We're going to go back here, and we're just going to say, now that those are selected, we don't have to bother with the canvas there. We're just going to say generate. And then because we've turned on ControlNet and some additional models, it might take a little bit longer to get going, but it gets going. And then we can see a preview. And there we can see it's a bit wonky, but it's essentially a render of our sketch. And that was done in 2 minutes. It kind of made my person into a little cutout person. But yeah, that kind of conveys the idea initially. And we can just say save. And basically at the moment, here where it's got the dice, where it's set to -1, that means it's going to be a random seed. But if we want this to be the exact same as that previous one, so if we can generate a new one, and it'll give us something different. And it's nearly done. And there we go. Maybe this one's a little bit worse than the other one. But if we wanted this to have the same seed as before, if we wanted to get the exact same result, we haven't changed anything, and we just make the seed this older images, the one we saved. That's the seed there, 2977. And we can say generate. And what it'll do is it will basically create, because it's got the same seeds, the same prompts, it will recreate that image that we got before. And then you can see that image has been created. And I'm just going to open the one we saved, and you can see that they're identical. So there's a level of control that you can get out of this process, so that you can control it yourself. So what this allows us to do is control the level of creativity. For now, we do want it to be the most creative, but let's say if we want it to be less creative and more true to our image, we can bring this down. Using the same seed, because we like this result, we can just say generate. But for our instance, because it's a sketch, there isn't really any details for it to pull from. So it's just going to go from an image closer to a sketch. So you can see there it got rid of a lot of details. But it's just a way you can control the process and maybe adjust this whole thing. So now it kind of looks like a SketchUp model with some photo bashing in there. Maybe we want something that's between those two, so I'm going to make it maybe 0.95, and we say generate. And then you can see it's closer to that that fully creative version. It's quite close, in fact. But yeah, this is just a way to go from a sketch to a render aesthetic, and a way to demonstrate your ideas, because sometimes the client can't really understand that, and sometimes you want to get something out. So here we say house in a lush green landscape. So I'm just going to say in a dry yellow, a dry savanna landscape surrounded by trees, modern architecture, and I'm just going to say timber house concept, photoreal morning, leave the rest, and then we say generate. And we let it go through its processes. While that's happening, I'll just show you. This is kind of, okay. Okay, cool. So this is our new environment. You can see it turned this into timber paneling, and it's quite cool. It's quite creative. It looks quite nice. And basically, the only thing we changed there was the prompt. The image is the same. The seed is the one of that one we liked, and we had this at 0.95. So I could bring this up to 1. I don't think there'll be much of a difference. But I can also just show you here. This is basically, it finds an outline. That's what the preprocessor does over here. This canny preprocessor. It draws an outline to say we need to conform to this shape. So when it can see your lines, it knows what to do with them. And then it says, let's fill that in with something. It's very powerful. So I'm just going to say generate again. And it's very similar, so I don't think this is going to be worth much of a difference. We're controlling it with the seed, so I think one way to create some more creativity with this is just to change the seed back to random. So you can just click on the random button, which just sets this to -1, and we can just say generate, and we get something that's a bit more exciting. But essentially, these are the ways you can do it. You've got your prompt, which gives it the aesthetic. And then you've got your image. This gives it the composition. And then you have your preprocessor, which helps you with controlling that. And then these models, this one, this MLSD, and this DVArch are specifically built for architectural rendering. So you can get buildings out of the normal one, like I showed you, like very pretty buildings. But it tends to deviate from what we want. So this is interesting. It's more of like a photo bash collage situation, because it's nice. It's still useful in presentation. You still get the idea. There's a staggered roofs. There's a staggered house coming down the slope, and there's steps. That's lovely, and then little retaining walls that go across. Anyway, that's just a demonstration of how you can take a sketch and turn it into a render of sorts. Let's go to see all the various ones that I've generated. If we can I'll just bring this up to there, and then you can see there's quite a few. I played around with it, getting different kind of results. They're not amazing, but they're aesthetically, they convey the idea more than a sketch. Some are a bit more than others. Sometimes it deviates from the shape. This wonky roof is definitely the fault of my own sketch. Some are beautiful, like this one is it's just a little bit of tweaking, and that I would say that's a finished render. And then this is that auto-generated image we did without any geometry. And then here, it's the same seed with it using our geometry. And then we brought it back to the sketch. And then here's the timber landscape, and that's the one that's slightly more of a collage. Anyway, it's very powerful, and I hope that was helpful. I have found a way to incorporate it into the workflow, and you're going to see it with this render that we produced now, because maybe we don't like this render. Maybe this render is pretty boring, and we want it to be just that bit nicer. So what we're going to do is we're going to go to our Stable Diffusion, go into our browser. We can say Control V. It opens up the Stable Diffusion UI, make sure that you have a model selected. The Stable Diffusion 1.4 is the one I'm using now. And then we're just going to turn on ControlNet. We're going to click ControlNet and I'm going to say enable. I'll show you the difference actually, with and without ControlNet. So what we're going to do is image to image, and we're going to take our render, the one we did of the house, and we're just going to say, what do we want this to be? We want this to be an outdoor courtyard, covered in greenery and sunlight. And we're just going to say it's a photo of an outdoor courtyard. Okay. And then our negative prompts, we don't want it to be blurry. We don't want a painting. We don't want a render. We don't want Unreal Engine. We don't want anything that makes it look fake, basically. Okay, most of these are fine. I typically turn this up to 8. The main toggle we're going to use here is the denoising strength. 0.7 is good. 1 means it can do whatever the hell it wants, and 0 means it's not going to change anything. So 0.75 is pretty good. The seed -1 means it's going to be random. If you wanted to repeat a seed, you just got to say reuse the last seed, basically. So then we got that, and we also want it to be roughly the same size as the original image. It's going to be 960. If we use the calculator, 1920 divided by 2, 1080 divided by 2 is 540. Okay, you don't want to go too high because otherwise your computer will not manage it. Basically, we want a ratio that matches our image, and then we're just going to say generate, and it should take about 30 seconds, I say, as I wait for it to happen. That is ETA. $10 seconds. Okay, brilliant. I mean, this is beautiful, right? Unfortunately, it looks nothing like our space. We actually wanted to retain a lot of that, but this is stunning. Flip. Yeah, I'm actually going to save that, and it saves with the seed name. So if you want to regenerate it, it's the name. That number on the name is the seed to generate it. The seed that goes here. So the difference is here we can go and we can turn on ControlNet. We come down to ControlNet. We say enable. We just need to select a model. I like to use the canny model. So we're going to use the canny model there. And then the rest of this is fine. And then here we can just use the same image, pull it in there. And then, well, I think we know it's going to look good. But let's say generate. And yeah, typically it takes about 30 seconds, but it depends on your machine. Okay, it gave us something that's quite nice. It's not quite what I wanted, but you know, it's actually quite good. So I'm just going to save that as well. And then maybe we're going to bunch it up all the way to 1 so it can get a bit more wild with it. So I'm just going to say generate. I think it's looking more like what I wanted. That looks nice. Okay. It's added an extra random thing there, but that's fine. Green, and I'm just going to say warm sunlight. And we're going to say generate. Okay, it's interpreted the shadow as like a architectural element. So maybe we got to pull back a little bit, just a tiny bit. So maybe we're going to bring this back to 0.8 and we're going to say generate. That looks quite nice. I think that has preserved it well enough. and it looks quite nice. And it looks a bit more like a photo collage, but also at a glance it looks like a photo. If we bring it down to 0.7, at around 0.5 it stops really changing anything and just kind of recreates what you've created. It's nice. It's looking very similar to our current one, so we can just generate again. But it's preserving the shadow, which is quite important. Again, not so great. Maybe one last try. This one is quite nice. I'm going to save this image. And maybe generate one more time. It's a bit addictive. Unfortunately, we have a tangent with our plant on the table and the ivy in the background, which doesn't really add to the... Okay, we're getting quite a similar result. This one's maybe a bit better. Alright, and then maybe let's just go all out again and see if it can give us anything nice. Wow, yeah, that's really nice, and it preserved the shadow even. I'm going to save that, yeah. That's quite good. Okay, cool. So we got quite a batch of renders there. This is our first very beautiful render, but completely random. And then here's a good start. It's quite green there. It's quite beautiful. It's a bit darker. It's closer to our original. Closer. Oh, that's quite nice, yeah. So this is the last one, and it painted the doors blue. Maybe we'll do that in the real one. I hope that sells Stable Diffusion. I hope that sells AI renders. It's quite simple. It preserves essentially what you are trying to demonstrate, and you could go back into the model and change the doors to a cerulean, or maybe be like, oh, like a light blue is a good idea, or no, we should change it up like this. You know, here it's kind of treating the bricks as like a siding, so it kind of looks a bit strange. And there's a few patches where it looks a bit weird, like here as well. I don't know what's happening there. But overall, it gives the an impression, which is kind of what these are. They're not photos, you know. You can make it more realistic. If the more detailed it is and the more control you have, the more you refine it. But it's a nice way to explore. But yeah, I hope that really sold you on AI and image generation. 5 seconds of FAQs. If you want to read it, just pause the video. And that's a wrap. I hope something was useful today. I hope you were able to take something and use it in your day-to-day workflow. But overall, I hope this allows you to see that there are always alternatives to what we think of as a standard or our only option, essentially. Have a wonderful day. Thanks for watching.